In this part, I want to show you how we can add more objects and add them to our simulation. And for that, I will just duplicate my basic setup. So let's duplicate this by just holding down Alt actually and dragging. And I will call this advanced. I mean, actually, it's really not that advanced, but yeah, just to make a difference from the basic setup. And we will just enter this advanced setup. So let's press I to enter it. And now let's add in another object to our simulation. So we can use this as it is because this is working nicely. And now I can just put in another object. So let's make a little bit of room here for our other object. And let's say I want to load in a file now. So to get something a little bit more interesting going. And I will just quickly navigate to my pack. I have actually a pack of 100 abstract objects for motion designers. You can also get this on my Patreon. So let's go to project and it's right here, procedural objects for motion designers. Here I have 100 different objects. Let's take one that could be funny, maybe something like, yeah, let's take this one here. That's a quite funny object. And I will just load this Houdini version that I saved, and that is also included actually in this pack. So you see, this is our file. That's what I want to use. So I will add a transform now and transform it up a little bit. Maybe we could rotate this just a tiny bit that it gets a bit more interesting. And I will move my collider object down here so that these both are colliding with it. And let's go to this transform here. Let's shift it over a bit. And let's actually scale it up a tiny bit so it's a little bit bigger. If we take a look at Shift W, you see that this is actually made out of quads, but that's perfectly fine for now. And the resolution is not that bad, so this will really simulate also very nice. I will use this as a soft body. So we will make a soft body out of that. So to add this object into our Vellum simulation, we have to create constraints, of course. So let's take a look at another way to create constraints. Last time I just used the Vellum constraints and showed you that you can set up all of the constraints types on top here, like so. There are some pre-configured versions here. If you type in Vellum configure, or velconf as I typed in, then you see we have Vellum configure balloon, Vellum configure cloth, Vellum configure fluid, and so on. And we also have this Vellum strut soft bodies. And for this example, I will use this. So let's click this and let's see if we put it over here, what Houdini creates. Now it actually creates two constraint nodes. These constraint nodes are exactly the same nodes as this one here, but they are already set up a little bit different. If you take a look here, this is already set to cloth. And I think that the values are pretty much the same as the default values here. But this one here is set to Vellum struts. So here we have struts constraints. Well, this is difficult to say. Okay, so now of course we have to bring this into our chain here, into our stream. So let's do that. And let's just connect these. So the geometry stream goes in here, constraint stream in here, and the collision stream in here. Let's just create a little bit more room here. Let's bring our collider up here. And let's make sure that we plug this into our collision geometry stream. Now, how can we bring both of these geometries in here now? And we have to tell Vellum somehow that these two constraints should influence only our file, and this cloth constraint here should only influence our planar patch. Let me actually rename this, that we really know what these are doing. Let me rename this to cloth planar, and let me rename this to cloth soft, because this is our soft body. Oops, cloth soft, and these are our struts soft. This way it's just a little bit easier. What we could also do is we could colorize all of these in the same color. So let's make these pink and these two, and let's make these another color, like maybe purple. and this one purple, and this way we don't get confused because now they have the same color. But of course we have to set this up and tell Houdini that these should influence this and this should influence only that one. And you can do this again with groups. So if you take a look at the constraint node, here you always see a geometry group, and here you can specify on which group this constraints should be created. So let's do that. Let's set up new groups. I will start with my file that I imported, and here I can just leave it in the standard settings because this will just create a primitive group. That's what we need because the constraints are actually working on primitives. That's okay. And we can now specify this and just call it our soft body. Now I want to create another group, so let's bring this over here and let's link it up here. And this will be my cloth. So cloth group, and if I take a look, you see everything is now inside this group. Let's also colorize these groups with our colors. You know that these are also inside our separated streams. Now I have to bring these streams together, and I cannot just connect both of these. Oops, I cannot just connect both of these in here. You see, this does not work. You know, you can only bring in one connection. So we have to merge them. Let's use a merge here. Bring this down here, merge both of these geometry streams together, and then we can feed it into our Vellum simulation. Right now, if you use it like this, Vellum doesn't know which constraint node should create constraints on which object, and it just creates constraints on all the objects. You can see this here. If I take a look at this cloth constraint here, it creates constraints on my soft body and on my cloth, but I don't want this. So I go to my group here and specify my soft body group, and you see now it doesn't create constraints anymore on my planar patch here. That's good. And I do the same for the struts, soft body, and I will do the same on this one because this is also creating constraints on my soft body, but I want to limit it to my cloth. And now I have exactly the behavior that I want. All of these constraints are now solved by the Vellum solver. And if we take a look at this now, just as it is, and let me do one more thing. I want to bring in a ground plane or ground floor because otherwise this object, this is not pinned. This will just fall down and vanish. You can do this in the Vellum solver. You can actually bring in a ground plane. In the solver tab, there is this ground position option. And you see now we have a ground position down here. So if I select my Vellum solver, make it visible, and then run the simulation, you will see what's happening now. So we have our cloth set up, and this is actually interacting with our soft body. And let me quickly turn off the other object. What we see here is, if you're really new to Houdini, is actually this basic simulation. And there is an option here where I can choose to hide other objects. So this will just hide other geometry or surface operator groups, other subgroups or subnodes. So back to our simulation, you see they're nicely falling down, and you can also see our soft body is very soft. So we may have to increase this a little bit because this is folding in itself completely. So let me show you the soft body, what's actually happening here. We have these strut constraints, I can't say it. So let me apply a pen and null here, again, to just visualize the constraints of these struts here. And now I am visualizing actually both of these constraints because this feeds it down here. So I have to disable my cloth constraints to see the strut constraints. And you see the strut constraints are actually volume constraints. So they are crossing the volume of our object and creating these springs inside of our object. If I disable the strut constraints, you see that these cloth constraints actually are only on the outside. So these create the hull. So our soft body is created by two types of constraints. These are these inner constraints that give an inner stiffness, and these outer constraints that is just the same cloth setup as we had it here. So what we can do to make this stiffer or more of a maybe a foam soft body is, first of all, we can go to our cloth soft body, and the stretch stiffness is very high. That is good. We could increase the bend stiffness a little bit, not too much, but maybe to 10. And then we can go to the struts here and change this stiffness that is set to 10, that's very low, maybe to a value of 100 for now, and just go to our solver again, and let's check how this looks now. So let's play our simulation. And you see now this soft body is actually has more volume, is a little bit stiffer, and yeah, it looks really good. So this is the option how you can add multiple objects in one simulation. And yeah, as you can imagine, if you add really a lot of objects, this can get a little bit confusing and a little bit complicated. And that's actually where the option to create these simulations, not in a SOP network like we do it here in a geometry environment, but in a DOP network, in a dynamics operator environment. That's also an option I will show you later in this tutorial series. But for now, as a next step, I want to show you how we can add forces to this simulation. So let's revert our simulation and let's check this out. I already told you that on the solver here, we have a forces tab and we can change these forces. We have gravity, these are just directional forces, and we have a wind, but we have nothing else here. So if you want to really add more complex forces, you have to dive into the Vellum solver. And to dive into it, you select it and press I. And now I want to pay attention on this here, up here. This is the navigation bar. So let's select and press I. And you see, suddenly we jumped into a few depths or a few steps further. The Vellum solver actually is this network here. And yeah, I have no idea what this is doing, but Houdini is so cool that you can take a look what it is doing. And if you have enough knowledge and if you want to dive into this, you could analyze this. So you see, but actually that this is actually containing a DOP network. And I cannot even find it now, but if I go back here and just double click, then we will jump into this DOP network. You see here it's DOP.net, and then we have this forces subfolder, and this is where we are now. So just that you know where you are somewhere inside the depths of Houdini craziness. And here we have the option to add forces. If we tab now and put in force, then we get a bunch of options here. You see we have pop forces, and if you're new to Houdini, pop means particle operators. And because we are actually in a DOP network, we can use these particle forces. So we can, for example, use a particle force. So let's just use this pop force. That's a funny one. And you can add it to the scene by just connecting it to the force output here. And this also has some wind forces, so some directional forces. We can put this to 5 on the x-axis, then it will blow into the positive direction on x. And you can also add in some noise. So let's also do this and make it a little bit crazy, so a very high value. You can take a look what we are doing actually here. So this is the positive x direction here, you see. You can take a look what you're doing with these guides here. We can make this turn off the roughness a bit. You can change the swirl size. I don't want to go too much into details now, but this is how you can set up a force. And if I play this now, let's turn off the guides because they are quite distracting. We should definitely see some influence on our simulation. So especially our cloth, you see that it gets blown away by this force. It's actually not that strong, you see, with an amplitude of 5, but our soft body is already running away. And here I want to show you one thing that we discussed before, and this is mass. So if I go now to my soft body here on the cloth actually, and change the mass of my soft body, because I think that this is way too light. So let's go into our mass here and change this from 0.1 maybe to a value of 2, so it gets quite heavy. And then let's run this simulation again. So let's run this simulation again. You see now, of course, again, it has also an influence on my struts because the cloth now is way heavier. You see that these struts are now suddenly being compressed even more. But it also has an influence on how our wind is blowing it away. So let's increase the thickness or the stiffness of our struts to 1000. And let's go back here and make this even a bit heavier so that we have some fun here. Let's set it to 4. And let's take a look what this does now. Now it's really heavy, it falls down quite fast, and you see it's still being blown away by this wind because, yeah, it's quite a strong wind. But I think it's blown away not that much anymore. Actually, I'm not sure. So I think it has some influence, and let's set it back to a very light value just to test this out. I'm actually not even sure what real influence this has. And now, okay, now I have some very strange collisions here. And yeah, this is also a good example. Good that this happened. So what we have here now is actually very ugly results. And sometimes this happens in Vellum. So first of all, I would say that this weight is not good with these struts. So now the struts are way too stiff and the weight is way too low. So let's maybe increase this a little bit so that it doesn't give us that crazy results. Something like that. And let's re-simulate this. Let's see what kind of deformations we get now. Yeah, now it's not that bad anymore. But if you have a really bad simulation with a lot of intersections, then there are some very important settings on the solver itself. And if we take a look at that, here we have substeps, and substeps and constraint iterations are quite important. So you can imagine this like that. We have 100 constraint iterations. So each frame, it sends 100 iterations over these constraints to solve their behavior. And then there are smoothing iterations that take out a little bit of energy of this simulation. And if I, for example, now increase the substeps, that substeps means it does it one time now per frame. If I set this to 2, now it will run these constraint iterations 2 times per substep. So now we have actually 400 constraint iterations per frame. And this sometimes resolves bad intersections and will also change the behavior of our cloth. So this is also very important to know. The higher you make the substeps, the more rigid or the more stiff these simulations get. So let's set it to a very high value of 4 and take a look at our cloth. So it really actually changes its behavior because now we calculate way more constraint iterations, and that's why these objects now get way stiffer, So this is what you have to keep in mind. And also, of course, the duration of the simulation, so the solving duration, will be way higher because we now run actually 400 constraint iterations per frame over this simulation. So this is very important to know that you can change this here, and in some cases you definitely need more substeps to create a nice result. Let me set this back to 1, and you can also lower the constraint iterations height here. So if we set this back to a very low value, for example, only 10 constraint iterations per step per frame, and you see, first of all, it suddenly looks totally different, It's not that stiff anymore, and you also see that we get a lot of problems now. So these are not enough iterations to solve all of these collisions, and you see it just doesn't work. We have things like collision passes, but yeah, I will not cover these right now because most of the time it's happening right here. So if you want to speed up your simulation, you can test out whether your simulation is so simple that you can get away with lower constraints here. But most of the cases, if you have complex simulations, you need to increase these values. You see that we can solve this simulation with 100 constraint iterations. So it works, we get no bad intersections. Let's see whether I can lower it to 50. Let's see where the breaking point is. And 50 seems to still work, but of course you see here we get some problems. This is now suddenly popping out. And yeah, it just doesn't look that good anymore. So I think we're already very at the limit. And if you now increase the substeps, this will calculate actually these 50 constraints 2 times. So we again have altogether 100 constraint iterations, but now they are calculated in 2 steps. So this is also not very good. In this case, it's really better to let the substeps at 1, increase the constraint iterations, and then we get more or less a nice result. If I take a close look now, I have some problems with these struts here. They are poking out a little bit here, as you can see it here. Yeah. And probably if we increase the substeps to 2, then this may fix that. Let's take a look whether this fixes it. not quite, but it already is better. And in this case, I would probably just go to the struts and change their value a little bit, make them a little bit softer again. And now I got rid of these problems here. So this is also something that is important for a beginner tutorial, that creating simulations always is problem solving and always is trying out different values. So it's a very long process to create good simulations because you have to try out a lot of different values, and the values change all the time. So it depends on the scale of your scene, it depends on the resolution of your geometry, it depends on your forces, it depends on so many things. And there are just no right or wrong values. You just have to experiment and put in the right values to get what you want. So I think that this is pretty much a good end statement for this part of a bit more complex simulation setups, and also about adding these forces to our simulations. Okay, so this is it with part 2 of our Vellum basics. In the next part, we will take a look how we can set up Vellum simulations inside dynamic operator networks, so inside SOPs. So let's continue and check that out.